1990, and that was 67 at that point. And otherwise, I'd have worked on as long as they'd allowed me. But I did stay on for closure, environmental closure, and I did consulting work with them and on the plant for about 3 or 4 years.
Okay.
And that was the end of the line. So I had 41 years with the 3 companies.
Yeah, right.
But I stayed right on as they were merged or bought out. I was working for one company on Friday and working for the next company on Monday.
Yeah, right. I sold my company to U.S. Filter,
Mm-hmm.
and they were bought out by Siemens.
Mm-hmm.
So my company really does not exist anymore. They bought out Permuta, they bought out Cochrane. I think they bought out Illinois Water Treatment.
Mm-hmm.
They were buying up all of the competitors.
Mm-hmm. Well, I should tell you, I'll have to get out here a little bit before 4:30. My sitter has another appointment, so we got about an hour and 20 minutes or so. to
Okay,
go.
all right.
We're in pretty good shape. I wanted to know what your sentiments really were about this business and about all mixed beds and clarifiers and
Mm-hmm.
all that stuff.
Well, we were talking a little about materials of construction there. In the early days, we used mostly 304, 316 stainless steel.
Right.
And later on, of course, the early plastics back in that period were left a lot to be desired. And we didn't, you get too much leachate from them. Some of the compounding was such that they didn't have, apparently, the components matched exactly, and you'd have problems with different chemicals leaching out. Later on, I think they got that taken care of, and that we were using plastic PVC
Yeah, right.
later on.
Right.
Larger piping, you get into 3-4 inch piping, we were using saran line, or later on, I think there was also PVC lined pipe as well.
That was a more exotic.
When you get into the ultra pure water, you got to start worrying about what you put it in if you want it to stay very pure,
Right.
because it's very hungry, chemical-wise.
Yeah. Did you do any work with ultrafiltration?
What size
Well,
would that be?
With reverse osmosis, some of that, but we were using Cuno filters, resin catcher filters on the ends of the demineralizers as they left the mineral. I don't know that you would call that ultrafiltration. No.
Well, they had ultrafiltration membranes.
Yeah.
I only did one job like that, and I was still puzzled by it. I did it for an outfit up in Boston.
Mm-hmm.
Can't remember the name of it, but the president of Mostec came up and ran that plant in Boston.
Mm-hmm.
And I put an ultrafiltration plant in their RO water line.
Mm-hmm.
And the purchasing department was particularly obnoxious. But the technical people were ecstatic about this ultrafiltration plant of mine. And I never knew really why they were so ecstatic. But they said that unit paid for itself the first week. Well, the unit cost $300,000 or something. So I never knew what they meant by that. So I was just wondering if you could shed any light on it. But there must have been particles in the RO water lines. And I must have been able to take them out. And then that meant that that affected the process in some way, but I didn't ever find out how.
Do you have other questions?
I wanted to talk about reject rate. You mentioned that in in South America, there would be occasionally be times when they'd throw everything out.
Yes, we
And,
had this in Fullerton, California, when we were on river water too.
Did what was an acceptable reject rate for, say, this is the highest and best use of good water back then? It was making black and white television tubes, I assume.
Well, the only acceptable to management was a zero scrap rate, but of course that doesn't seldom happen all the time. But gosh, you got to get down into couple of percentage type of reject. You can't reject a high level of.
Well, let's hear about what those were. Was a high reject rate 5%? Was a high reject rate 2%? I mean, you give us some ideas. 'Cause I'm positive this connection between pure water and reject rate exists. Well, I'm not positive, but I think it might.
Well, I'd have to come up with what I think are reasonable, other than I don't remember. The plant ran what they ran, and the goal, of course, was always to have a zero, which, of course, virtually never happens. You have something that will cause a problem once in a while, but, I would say certainly at 5% would, less than 5% would be an acceptable level.
Yeah, I agree. Yeah, I agree.
Well, let's hear a product reject rate from Austin.
Texas Instruments at one time threw out 80% of their product because it failed tests, and that meant that 20% was satisfactory. But when I made the conversion to the clarified water, it swapped so that they were producing 80% and only throwing out 20%, and they considered that okay. That was their minimum acceptable.
What year was that?
62.
62. And what were they making in 62 primarily?
So all semiconductors.
Well, they were
No.
making transistors too, were they not?
But the little chips were 2,000 sites of memory. Today there are 2 million sites of memory, but then it was 2,000 sites. And I don't suppose that it's changed tremendously going from 2,000 to 2 million. But it may have, and I don't know anything about that. It's amazing that they could have 2 million sites. They have atomic sites on semiconductors now. They're down to atoms.
You don't have to understand that completely, I think, but the chip in this camera is less than an inch square, and it has 32 gigabytes of storage on it.
I mean, that's just, I can't even conceive of that.
So it goes kilobytes. You had 2 kilobytes, and it goes to what, megabytes?
That's million.
Let's see, 2 kilobytes. You have 2 kilobytes, then it goes to megabytes, and then it goes to gigabytes. So this is over. You can calculate that, right?
1,000 to 1. I don't know what it is.
Let's see,
I don't know what a
1,000
gigabyte is.
million. It's over 10 million times as much as those 2,000.
That's crazy.
Isn't that right? I
I
hope
can't
my calculations are
conceive of that.
It's just unbelievable what they do with these
Isn't
things.
it unbelievable
It
what
is.
we did originally with where they're at now? Little chip has got 2 gigabytes. How many?
32 gigabytes. And there was also another one available next to it that was 64 gigabytes.
Unbelievable.
This is all, you remember how much you had to store in what a videotape looked like? It's a chip, it's an inch square chip like this.
Right.
Yeah.
Exactly. Now, what does a 32 gigabyte chip cost?
It was about $32.
32 trillion. $32?
I'm not going to get into the numbers. It was just, it did not seem like a big deal considering
Trillion
it tape
is as
for
big as I can
6
think about.
hours or something.
32
What
bucks.
do you do, incidentally?
I'm pretty much retired and travel a lot.
Retired?
But I was in real estate, something extremely
Oh,
boring.
I see.
But I did work with my father right out of school, and it's the only reason I sort of understand what you guys are saying to each other. So.
So was your training in engineering or
I was a business major,
businessman? Okay.
but with exposure to this stuff, I learned a lot of water chemistry, you know, titration tests, and that sort of thing.
He has a basic understanding of all of this stuff. He always kept involved. He worked
There was
for
never
people.
an interest in my generation into going into engineering, and there should have been, but that's just the way it was. So, in putting together these plants for Sylvania, you did these solely with the intent of making water that was acceptable to them. 1 megohm water.
Well,
Anything beyond that was just free. That was,
that was our criteria for, say, going online and offline.
So,
It
6 to 18
produced
meg was
satisfactory results.
You really wanted 18 meg water.
yeah, by the time it got down to Texas Instruments, they wanted 18.
But that was just a cutoff, so that was not overly important because there was not much water involved.
So that was the measurement, you were measuring it at the demineralizer.
That's right, in the
And-
pipeline,
and then
immediately following the demineralizer.
Was there measurement at that time at the point of use?
Normally, no.
That's because the instruments were just too expensive or hard.
Point of use, Mick, was a whole bunch of women
Yeah, okay.
doing all kinds of stuff, so there was no point of use testing. If you got in trouble, it probably wasn't point of use testing, but normally it was just leaving the plant was considered satisfactory, and it really did not change.
Well, as your father and I were talking a little bit ago, I recall you were out to get your coffee. You have to pre-treat your water to the extent that basically the demineralizer sees no contaminants.
Mm-hmm.
If you can keep the resin ion exchange free of contaminants, you can continue to produce the quality of water that you want.
What would you call contaminants?
Well, everything from particulate to things like
Slime.
excess chlorine, anything that breaks down the resin, any kind of organics that really do a job on fouling the resin.
So your first thought is make the water pure enough
Absolutely.
to get into the demineralizers. And the demineralizers, if they're taken care of, can take care of the rest of the
That's
system.
right.
I see. Okay.
And that's where the flexibility of the clarifier comes in, particularly on surface waters where you have to be capable of treating a varying source of water, because no surface water stays the same all the time.
Yeah, it varies, that's it.
All the
You never know
time.
what you're gonna have to treat.
And that's the reason that the well water, deep well water, tends to be consistent the year round.
Mm-hmm. Mm-hmm.
But so really, in this day and age, certainly you would, any kind of surface water, you would start with a clarifier. And you do as much pre-treatment as you can and feed the demineralizer as completely free of contaminants other than the mineral content. That the purpose of the mixed bed demineralizer is to remove the mineral content.
Mm-hmm.
And anytime you start using it to remove anything other than mineral content, you're starting to foul the resin,
Mm-hmm.
and it's not going to produce the ultra-pure water that you want.
Now, after it goes through the demineralizers, the carbon filters, I think there's a deaerator in the system at some point now in some of the.
Texas
places.
Instruments always vacuum deaerated their water to remove the oxygen.
Then
want
you have to
oxygen
keep
in the
it
water.
pure.
Right. Well, I'm sure the semiconductor operations are more critical to see resin will, you can get some fines or a gradual attrition of the resin breakdown, so you got to do as much for particularly your semiconductor, a very good job of filtration so that you don't get any particulate on the product, which that was not as critical to the TV tube operation.
Did any of your other plants use vacuum deaeration?
I'm sorry?
Vacuum deaerators to remove oxygen, carbon dioxide, and stuff like that?
They pulled a vacuum on water, made it boil, pulled out all the dissolved gases.
Well, we used aerators where, as shown in the diagrams here, we were using it in the Ottawa plant. If you have a high content of bicarb, if you can blow it out with an aerator, see, we used out there, we'd use the pre-treatment, the demineralizer, two-bed demineralizer with low base resin. A low base won't remove your bicarb.
Yeah, right.
So after you see your cation, much of your hardness, magnesium calcium is in a carbonate form. And when you remove the metal, you attach a hydrogen to the, and make H2CO3. You can remove that by using an aerator, which is cheaper than doing it with high base resin.
Yeah.
So in that Ottawa plant, we would use an aerator here, blow it out as CO2, and then put it through the mixed bed demineralizer.
Yeah.
I see.
So
That's interesting.
It's a matter of economics. It's just cheaper to do it that way than it is to use this high base resin and low base resin.
H2CO3, those break, that split or combine with other H2CO3s to make to make a carbon. How does that work?
Carbon dioxide is H2CO3 in water.
Yeah.
Okay.
So
H2CO3 becomes carbon dioxide.
Okay.
yeah.
So it's easy to blow out.
So they're tailored. Your systems have to be tailored to the individual water.
You tailor it. It sounds like as far as the demineralizers, you get the water down to a certain basic
That's
thing
right.
by the demineralizers, and after that, you treat it. So there must be a sort of a standard for pre-demineralized water. Is there no organics, I guess?
Well, ideally, you want it
no.
as free of organics and other materials other than the mineral content, because the demineralizer, its function is essentially remove the mineral content. It's not
No particulate matter.
Well, you don't want to remove particulate matter in the
Demineralizers.
or you're going to foul up the resin
Yeah.
bed too. So the idea is to get everything out if possible before it hits the demineralizer, except for the dissolved mineral content.
Right.
That's the specific purpose for which your
No
demineralizer.
chlorine.
Hmm?
No chlorine.
No
Take the chlorine out.
chlorine, because that breaks down the resin.
Okay, a question. Ultra-pure water is a term now. It's an accepted term. What did you call it back when? When did you first hear of ultra-pure water?
Later on.
Well, I think that's a later term that has come up. And
Might be the magazine
I don't-
people dreamed it up.
Might be.
remember We usually just referred to it as high purity demineralized water.
Right.
Uh,
With high purity.
I think the ultra pures come more perhaps from the semiconductor industry. Would be my guess. I don't know, but I don't recall using this term as during my work at any rate.
I never used it. Ultra pure. High purity.
Ultra pure, high purity.
High purity, right.
Okay.
Yeah.
The interesting thing you mentioned though with the with new resin. No matter what you did, apparently, as long as you had new resin, the first water that came out of it was
Well, 18 mega.
18 mega. Yeah.
You say if you put it on at 1 megohm, and it jumps up quite rapidly to 18 megohm, runs up here and then drops down. Now, when the resin is not foul, this is quite sharp. As the resin gets foul, this gets to be a curve.
Rolling curve.
Keeps coming down and down and down, because as the resin gets foul, it won't produce the 18 megohm water.
Yeah.
All right. Let's see here. Technical journals or papers or individuals who may have been helpful to you in this especially pure water. I mean, I don't know
Well,
what.
the premier handbook was the Bible, as far as I still have one. It was the Bible as far as, you always go back and read that if you got a problem.
Right.
But it didn't say ultra pure in there once. It didn't say.
Well, it was, it was used probably more for pretreatment. Mine doesn't have too much, I don't think, on demineralizing. I don't know, it's been a long time since I've looked at it.
You have one of the black ones with the black cover. You have one
No,
of those white ones with a scroll.
mine is later. It's kind of a purplish color. It's a big book, actually. The little black one, I think, was a smaller
Yeah.
book, if I remember
Yeah.
correctly. The one I have is almost a regular paper size.
Yeah. Right.
It's a bluish or purple. I think it's more bluish in
I've
color.
never ever
about
understood that
thick.
everybody liked that book. I mean, everybody asked me for that book,
Well, it covers all kinds of treatment,
Yeah.
boiler water treatment and you name it, which is
Treatment
great.
for water for steam trains.
Yeah.
Remember that was in there.
Yeah.
Lime treatment, sort of.
Everything,
Yeah.
right. No, that was really the Bible that you always went back to and reread again when you had a problem.
Yeah.
Yeah, I got involved in all the boiler water treatment and all this type of thing too in the plant, so we had to handle we handle all kinds of things.
Yeah. I bet they threw everything at
Unbelievable.
you.
And it
Yeah.
took you for granted.
Yeah.
It took you both for granted. So I think we came here today with the idea of finding the means by which you got to the point where you were making decisions on what treatments to use for specified water. I think you've done that. You've done that. I need to tape
Explain
you.
what Ed has said.
All right.
Ed says that if you can make ultra pure water out of whatever, then it's only called ultra pure water when it's ultra pure water. Doesn't have anything to do with pre-treatment or any of that stuff. It's whether you can make ultra pure water out of it. And you can make ultra pure water out of deep well water more easily than you can with surface water.
Okay.
They're both ultra pure water. I had tried to make a distinction between the two.
Theoretically, you could take any water and make ultra pure water out of it.
Right.
Or you can
Treat it.
boil water on the stove. You know, I mean, the thing is that this was a commercial ultra pure water plant that didn't rely. Let's see, Texas Instrument plant anyway did not rely on the quality of the water to begin with. It's like It's like if you want apples, you'll go to obviously an apple tree. But with water, if you want good water, you can start with anything now. You can start anywhere, and you can purify it to ultra pure standards.
Well,
If
what
it will
you,
purify, you have ultra-pure water, if you can purify it.
Yeah.
you have to tailor and build the system to match the water that you start with.
Right.
So it's the end point that you define the water, not the pretreatments or the lack of pretreatments.
Okay.
That's the end quality that determines what the water is called.
Too many people, average individual, water is water.
Yeah,
And
unfortunately.
that's not the case at all. Every water has its own characteristics, and they're no two exactly alike. And the first thing you do is you go and get as much information ahead of time, sample and analyze. And ideally, you would sample at different times of the year to catch runoff and things like that, so that you know what you got to deal with. And then you, from the basic laboratory data, you start to formulate what you need for equipment and build the system that you have to have in order to produce what you want on the
Only
end.
somebody with his talent can do that. You just can't let somebody else just happen to do it because they may not know what the hell they're doing.
It's not a cookie cutter deal at all. And of course, if you're selecting a plant, as we were talking before, you would look for a stable water supply. And too many people don't, too many industries don't do that. There's a lot of reasons why they locate plants in certain places, but if water is a big problem, certainly we learned that you should try to find a good water source that should keep your water treatment costs to a minimum, particularly where water is such an important part of the process.
There was a Sylvania plant. It turns out Sylvania was the third electronics manufacturer in the Silicon Valley.
So they had a plant in, where was it? I can't remember. It had nothing to do with TV, but it was some kind of an electronics plant out there. I was not involved with that.
When I was in Silicon Valley one time, maybe 15 or 20 years ago, I saw this enormous vertical clarifier, probably 40 foot in diameter. You know, Silicon Valley has, 6 and 8 foot diameter, everything, but this clarifier was way above that. But it looked like a permitted clarifier, but I never found any validation for that.
Was that Fairchild?
What was the name
Was
of
it at Fairchild? I think you told me one time it was at
I
Fairchild.
think it was at Fairchild, yes. Did you ever know of Fairchild?
I had no.
They had a big plant out there in California anyway. But
That would have been in the 70s? That would have been in the 80s?
I would say that was in the 70s.
All right, well, that's 40 some odd years ago.
Yeah, well, reverse osmosis really started in 1970, early installations. I put one in a TI in '69, which I think was the first one. And we did research on the DuPont and Roga membranes, and the TI liked Roga. They did not like DuPont. DuPont had a hell of a hard time in the business. They finally ended up in the seawater business, and their membrane was good for seawater because it was being flushed all the time because only 10% was being taken out. Whereas most waters, they took out 75%, threw away 25%. Because you were pressurizing everything.
Well, there's a lot of things you have to watch in a demineralizing system, and this includes your regeneration chemicals, the purity of those, and so forth. Because if you get a poor grade of caustic or sulfuric acid or hydrochloric acid for regeneration, you can foul the resin
That's
up as
interesting.
well. So there's a lot of parameters that you have to keep your fingers on, keep track of to make certain that you don't get back into the fan, so to speak. It's not all that simple. There's a lot of things to watch and keep track of.
I'm going to take a break.